Okay. On the topic on linear equation of order 1, we are tasked to get or to solve for an integrating factor. What's the use of finding the integrating factor? The integrating factor is a factor that when you multiply it to a certain function, it becomes a perfect differential. So this topic will give you premise on how to solve a differential equation by having an integrating factors by merely by inspection. Okay, this method is actually very useful in getting the solutions fast. Of course, if you develop the skills of inspection. So at the end of this topic, you're able to recognize exact differential in a differential equation of order 1. Okay, that's one. And then determine an integrating factor by inspection, of course. And then find solution of a differential equation by inspection. Okay, so this is actually concerned with equations that are simple enough to enable us to find integrating factors by merely looking at it and by inspection. Of course, the ability to do this depends largely upon the recognition of certain common exact differentials, and of course, by experience of solving several differential equations. So the following are common exact differentials. So on the left side of your screen, we have d of xy. Of course, the derivative of xy is equal to x dy plus y dx. And then the derivative of x over y is y dx minus x dy over y squared. And the derivative of y over x is equal to x dy minus y dx over x squared, and so on and so forth. So the first thing you have to do is to recognize that these exact differentials, maybe one or two or even more than, are present in our equation. Okay, for us to understand further, we have to take a look on the following examples. If we have here an equation, we have y dx plus x plus x cubed y squared dy, that is equal to 0. The first thing we have to do is we have to distribute. So y dx plus x dy, and then x cubed y squared dy, that is equal to 0. Now, we have to regroup it. So we group this one with those that with the same degree, and then this is plus. Now, if we try to divide x cube y cube in here, x cube y cube in here, what will happen? So we have y dx plus x dy over xy cube plus dy over y, and that is equal to 0. Now, if we try to, this is differential, right? This is an exact differential. Now we put this one into a negative exponent, so we have x y to the negative 3, and then the exact differential xy, dx of xy, plus dy over y, and that is equal to 0. Now, if you notice, this one is in the form of a power rule, right? Now, if we try to take the integral of this one, so how is it? So we have 1 over 2, and then xy, of course, to the negative 2, plus ln of y is equal to, we can put this one also as ln of c, wherein ln of c, still c, okay, still a constant. Negative ln of c, of course, is still a constant. Now, what happened is that we have 1 over, sorry, that should be negative. x squared y squared, okay, plus ln of cy. We can actually combine this. So that will be ln of y plus ln of c, or that is actually equal to ln of cy. Now, if we put this negative 1 on the other side, we have ln of cy is equal to 1 over 2x squared y squared. And then to simplify it further, we have 2x squared y squared ln of cy is equal to 1. So notice this is already your final answer. Okay, so this is solution of a differential equation by inspection. Okay, for example number 2, if we have here if we have here y times the quantity 2xy plus 1 dx minus x dy is equal to 0. So the first thing we have to do, of course, is to distribute. So if we try to distribute this one, we have y or 2xy squared. We have 2xy squared plus dx plus y dx minus x dy is equal to 0. And then the next thing we have to do is we have to group. So 2x y squared dx plus y dx minus x dy equals 0. And if we try to divide y squared in here, also y squared in here, what happens is it cancels out, and then 2x dx plus y dx minus x dy over y squared. That is equal to 0. Now, are you seeing an exact differential? Yes, this is an exact differential, this one. So what is it? So we have 2x dx plus, this is d of x over y. That's equal to 0. Now we try to integrate these terms. So this is x squared over 2, right? So that is, we have x squared plus x over y, and that is equal to c. Or, if try to simplify this further, just put it in here. So we have x squared y plus x is equal to cy. Or, that is x and then xy plus 1 is equal to cy. Now this is already your final answer. This can also be your answer already. Okay, so let's have another example. For example number 3, we have here y is equal to the times the quantity x cubed minus x dx plus x times the quantity y cubed plus x dy is equal to 0. So the first thing we have to do is, of course, to distribute. So if we try to distribute this one, so we have y to the fourth dx minus xy dx plus xy cubed dy plus x squared dy, and that is equal to 0. Now, if we try to divide 1 over y, if we try to divide y cube on each term, on all the term, so y cube, what will happen is this. We have y dx, right? And then multiply this one in here first. So we have plus this one, okay? Y, x dy. And then minus xy dx plus x squared dy over y cubed, and that is equal to 0. What we will do now is that we have to uh, we have to factor out the upper term. So we have y dx plus x dy minus, of course, we have to factor out x in here. So you have y dx, of course, we have minus x dy, okay? And then for exact differential, we have to put y squared in here. So since this is y cubed, the other one is put in here. So that is equal to 0. Are you sensing an exact differential? Yes, of course. So we have here, if we group this one, so we have d of xy, okay, minus x over y. And then this is an exact differential of x over y, right? And that is equal to 0. Now, we can already integrate this one. If we try to integrate these terms, so we have, of course, this is y, okay, minus, you notice the derivative of this one is, of course, this one, okay. If we put this as our u, our du is this one, right? So therefore, if we try to integrate that one, that will be 1/2 of x over y squared, and that is equal to c. So looking at this one, this is already your answer for example number 3. Okay? Okay, so let's have another example. For example number 4, if we have here y times the quantity x squared plus y squared minus 1 dx plus x times the quantity x squared plus y squared plus 1 dy is equal to 0. Now again, we have to distribute. So we have x squared y dx plus y cubed dx minus y dx, okay, plus x cubed dy plus xy squared dy plus y, x dy, rather. So we have x dy, and that is equal to 0. Now, what happened is that we have to group. So how's the grouping of this one? We have x squared y dx plus we have x cubed dy. Okay, so this is one group plus another group is we have y cubed dx plus xy squared dy. Okay, plus we have this one x dy. What is left is x dy minus y dx, and that is equal to 0. Now, looking at this one, if we try to factor out x squared in here. So x squared and then y dx plus x dy. Okay, we can also factor out the y cube in here, y squared in here. So y squared, and then what happened is y dx plus x dy. Okay, plus x dy minus y dx. That is equal to 0. Now in algebra, you can also factor out this one. So we have x. Okay. Notice the GCF in here is y dx plus x dy, right? So therefore we have x plus y. Or if you are more comfortable of the GCF, let's factor out the GCF first. So we have y dx plus x dy. Okay, what is left? We have x squared plus y squared. Okay, plus x dy minus y dx is equal to 0. Now, if we try to divide x squared plus y squared in here, also x squared plus y squared in here, notice this cancels out. What is left is y dx plus x dy, okay, plus x dy minus y dx over x squared plus y squared, and that is equal to 0. Now, are you seeing an exact differential? Of course, yes. These are both exact differential. So this is actually d of x, y. How about the other one? It's also an exact differential, that is d of, what is it? The arctangent of what? Tangent of y over x. Okay, and that is of course equal to 0. Now, if we try to integrate these terms, what will happen is we have xy, okay, plus the arctangent of y over x is equal to c. Sorry, it's no longer. That's it. So looking at this one, this is already your final answer. Simple as that. Okay?